All right, hello everyone, this is Mr. Crozier. I'm going to go over some of the key parts of this packet. First off, we have all this computation without a calculator. I will be making another video this weekend and more practice problems for the computation without a calculator, so you want to watch that one. But now I'm going to go through some of this stuff down here. Number one, our equation for the unit is y is equal to ab to the x, an exponential equation. However, we do have some variations of that. And this first one is a variation. It says that the amount of COVID infections has been increasing by 5%. When you see this word increasing, you're going to start with a 1 and then add on that extra rate. So that's 5.25%. So, and the way you type that in your calculator, you have 800 times 1 plus that additional amount of interest, parentheses, or in this case it's just a percentage, and you're going to raise it to the power, and I always put this power in parentheses up here, to the 5th power, because later on you're going to want to make sure that you have this whole exponent in parentheses. Now when you get to number 22, you see the word continuous right here. Well, that leads you to this equation, the continuous equation. So it's still 800, but now we use the number e. And see how it starts this parentheses for you, just like I did before, and we're going to put that same rate in there. But this time we're not adding it to 1 because continuous interest is a whole different formula. And we're going to put times 5 and we're going to close the parentheses. So this whole thing right here is in parentheses. And that's the key. A lot of people forget that last parentheses right there. You do have to close the parentheses. Press enter, and that's the amount there. Going forward on the graph, just make sure when you do your exponential graphs, you have this line here, which is your asymptote right here. When we did our sine waves, this was the midline. On these equations, that is that line right there where the graph approaches and where it goes away from. So you can get that line, and that makes your graphing a little bit easier. On the second page, we have a composite function. First you have to do g of 16, run it through the log equation, and then take that 2 and then run it through the f equation. On number 25, we just plug it in. On 26 and 27, you're doing nothing but changing it from an exponent form to a log form. You don't have to do any work with this problem. You're just changing it. 28, put a 27 there. And again, remember what exponents ask. They ask remember what logs ask. They ask what exponent is needed to carry a 3 to a 27. When I can't do these problems, I just come out here and I rewrite it. 3 to what power is 27? Then I'll know the answer is 3. 29, figure out the exponent needed to convert a 5 into a 25. On this one, you get the same bases and then use the power to power rule. 31, we have an equation, and here's one where the calculator messes you up a lot. If we're going to put in 30 times 0.5 raised to a power, right here's where you need to make sure you put that in there. And see how I put parentheses at the beginning and the end of the exponent. If you don't do that, your calculator is going to do the wrong thing. So we have 3.05. Same thing here, and look at this rate again. We start off with y equals ab to the x. However, my rate is going down by 20%. So I start at 1 and I move down. You don't see the word continuous there. There's the value of the Chevy Silverado. On the next one, here's the equation. If you see the word continuous, that is such a big clue. It leads us right to our needed formula. Plug it in, and there's the curve going up. Now this equation right here, number 34, you don't see the word continuous, you don't see the word increasing or decreasing, they simply tell you the rate. So you just use the rate. If you're told the rate, that's all you have to do is use it. 35, again, he's adding 10%, so add 10%. It's not the rate, it is add, and then this one is continuous, because you see the word continuous. So right here are three great examples: continuous, adding a rate, using a rate. Those are the three options. You either use the rate, add or subtract the rate, or have the continuous. Make sure you know this right here. This problem right here is 2 to the third and then made negative. A lot of people mix these up. If you have negative 2 squared, well, that is negative 4. If you have negative 2 in parentheses squared, it is positive 4. So it is a little tricky, but that is the way it works, and your calculator will do that. 38. What exponent do I need to take a 2 to a negative 32? Well, that's not possible. You're not going to get negatives. If you remember what the graph of this looks like, there is that asymptote right there. This graph does not go negative. You can't get to a negative number. And if you try and do that on your calculator, you're going to see if I try and do log 10, well, that's a 1 because a 10 to a 10 is 1. But if I try and do log of negative 10, calculator can't do that. Can't take the log of a negative number. The equation's right here. You can plug them in and round. On the back, let's see what we have here. The first thing I do when I see these equations is I graph that midline right there. Or actually, it's an asymptote. In sine function, it's a midline, but that's the asymptote, and you'll see these values come down and get closer to it. Number 41. I'm increasing by 12%, so I went up from 12.5%. Colony of bats, continuously. Well, continuously is right there. Three options, continuous is right there. X, 2, 36, something squared makes 36. Like we already know the exponent is 2. What base? Well, it's a 6. 4 to the 5th is equal to x, 10,024. In this problem, same thing here. If I know this pattern that it becomes 4 to the 5th is equal to x, that same pattern goes right there. 2 to the 5th is that. 2 to the 5th is this. Solve the equation like an algebra student. Same thing here. Solve it like an algebra student. And the last one, if I get my bases to both be 3, squared here, now I can set these equal and solve it. It's x to the negative 3/4. All right, I hope this helps. I will be doing another video this weekend with a lot more of these, but you really want to practice these. If you can't do them by hand, you can always try stuff on the calculator to just check them. 5 to the 0 is 1. Now I could check this one, right? 4, 3 to the negative 1/2. Which is 0.4 repeating, and I could do this, and that's 4/9. So you can check a lot of this stuff on the calculator, and even your calculator will do this one for you. Negative 11 squared would be negative 121. Now if I put that negative in parentheses, now it's going to be positive. So you can do that, check it. Even this one down here, watch. 6 log of 10. 1. You won't have a calculator for this part of the test. However, it's a good way to check it. All right, hope this helps. If you have any questions, please email.